A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. So, I was looking at my desktop the other day, and I realized it's starting to look less like a workspace and more like a life support system for about 6 different AI agents. It's getting crowded in there.
Herman Poppleberry here. And honestly, Corn, if your desktop isn't crawling with autonomous processes by now, are you even living in 2026? But you're touching on exactly what Daniel's prompt is getting at today. We're seeing this massive architectural schism. On one hand, you've got these resident assistants that live in your local file system, and on the other, these cloud-native orchestrators that live on a VPS.
Right, and today's prompt from Daniel is about this exact tension. He's looking at the split between local first personal assistants, like OpenClaw, and the cloud-centric models that prioritize portability. It feels like we're trying to decide if our AI should be a roommate who lives in the spare bedroom, or a remote consultant who zooms in from a data center in Virginia.
It's a great framing because the trade-offs are becoming really sharp. By the way, quick shout out to the tech behind the scenes. Google Gemini 3 Flash is actually powering our script today. It's helping us parse through this agent identity crisis.
I like that. Agent identity crisis. Because if I'm using something like Claude Code or OpenClaw, it feels powerful because it can see my screen and touch my files via the Model Context Protocol, or MCP. But the moment I switch from my iMac to my laptop, I feel like I'm moving house. I have to pack up all my JSON configs, my local MCP server environments, my SSH keys. It's a mess.
That's the environment-bound problem Daniel mentioned. When you go local, first, you're essentially marrying your hardware. You get the high bandwidth, low latency hands of the agent. It can use vision to look at an Excel sheet or a legacy app that doesn't have an API, but you lose the ability to just walk away and have that task continue seamlessly in the cloud.
And Daniel made a really biting point about porting local CLIs to remote contexts. He called it nonsensical. It's like we're trying to turn our workstations into self-hosted servers just so we can access our agents from elsewhere. It feels like a Frankenstein architecture. Why would I want to tunnel into my own sleeping MacBook from a coffee shop just to ask an agent to run a git commit?
Well, not exactly, but you've hit on the core absurdity. If you're self-hosting a local agent just to make it remote accessible, you've just built a very expensive, very fragile private cloud. If your home internet goes out or your cat steps on the power strip, your omnipresent assistant is suddenly lobotomized. You're maintaining a server that wasn't designed to be a server.
It's like trying to use a chainsaw to cut a birthday cake. Sure, it technically works, but the setup and the mess make you wonder why you didn't just use a knife. So, let's dive into the first half of this, the local first architecture. Why is everyone so obsessed with it right now, despite the silo problem?
Well, for me, it's the vision and the computer use aspect. If I'm running OpenClaw locally, it's not just sending text back and forth, it's taking screenshots, performing OCR, and clicking buttons. If you try to do that from a cloud VPS, you're basically trying to stream a high-res video of your desktop to a server, have the AI process it, and stream the mouse movements back. The latency alone makes it feel like you're playing a video game from 20 years ago on a bad dial-up connection.
I tried that once with a VNC setup. The agent spent 3 minutes trying to click the file menu because the cursor kept lagging behind the actual window position. It's infuriating. But when it's local, it's instantaneous. It feels like the agent is actually inside the machine.
The technical hurdle there is massive. When an agent is local, it has direct access to the display buffer. Frameworks like Anthropic's Computer Use SDK, which really paved the way for this back in late 24 and 25, rely on that tight loop. If the agent is resident, it can react to a pop-up window in milliseconds. In the cloud, you're dealing with network jitter, packet loss, and the sheer cost of egress for all those screenshots. Think about the bandwidth. If an agent takes a screenshot every 2 seconds to see what it's doing, that's gigabytes of data, an hour just to move pixels to a brain in Oregon.
Plus, there's the MCP factor. I've been playing with some local MCP servers lately. One that connects to a local SQLite database, and another that hooks into my local Obsidian vault. That data never leaves my machine. The agent queries the local server via standard input-output, gets the context, and does the reasoning. If that was a cloud agent, I'd have to upload my entire life to a vector database in the cloud, just to give it the same memory.
And let's talk about that upload for a second. If you have 10 gigabytes of markdown notes in Obsidian, syncing that to a cloud vector store isn't just a privacy nightmare, it's a maintenance nightmare. Every time you change a sentence, you have to reindex. But with a local MCP server, the agent just asks the local file system in real time. It's the difference between having a library in your basement versus having to mail every new book you buy to a storage unit across the country and then calling them to read it back to you.
And that's where the privacy argument becomes a powerhouse for the local first crowd. With the January 26 update to OpenCloud, we're seeing better support for local inference. You can use something like Olama or Llama.cpyet to handle the sensitive thinking locally. Maybe you use a local model to scrub PII personally identifiable information before sending the high-level logic to a big model like Claude 3.5 Sonnet or Gemini. It's a tiered approach to intelligence.
It's the bouncer model. The local small language model acts as the bouncer at the door, making sure no social security numbers or private API keys get on the bus to the cloud. But even with that, you're still stuck in the silo. If I'm at my desk, I'm a god. If I'm on my iPad at a cafe, I'm a peasant.
But man, the configuration sync is the killer. Have you tried syncing MCP environments across 3 different machines? You've got different paths for Node, different Python virtual environments for your servers, different API keys stored in different secret managers. It feels like I need a full-time DevOps engineer just to keep my personal assistant working. I spent 4 hours last night just trying to figure out why my Google Maps MCP tool worked on my desktop but threw a path error on my laptop. It turns out I had NVM installed differently on both.
That's exactly the configuration drift that kills local first setups. That's why Daniel calls it a silo. You're building this incredible bespoke brain that only fits in one skull. If that skull your laptop gets stolen or breaks, your agent's working memory and its ability to interact with your specific world are basically gone unless you're religious about your .file backups. And even then, restoring that environment on new hardware is a day-long project.
So let's look at the alternative. The cloud-centric model. This is where you're deploying agents on a VPS or using something like LangGraph Cloud. This is the always-on dream, right? I can send a request from my phone while I'm at the gym, and the agent just grinds away on a server.
Right. The cloud-native model is all about persistence and orchestration. If you use a framework like Crew AI or LangGraph, the agent isn't just a script running in a terminal, it's a state machine. It lives in a database. If the server reboots, the agent picks up right where it left off. It can handle webhooks too. An email comes in at 3 in the morning. A cloud agent can wake up, process it, trigger a GitHub action, and have a report waiting for you when you wake up. It doesn't need your laptop to be open to think.
But it's blind, relatively speaking. How does a cloud agent deal with my local environment? If I wanted to organize my local downloads folder or see a bug in a local dev environment that isn't pushed to GitHub yet, it's stuck. It's like a genius in a padded cell with a very fast internet connection but no windows. How do people actually bridge that gap without it becoming a security nightmare?
Well, that's where the agent-to-agent or A2A protocols come in. We're starting to see cloud-native frameworks, especially in the enterprise space like Microsoft's Agent Framework, use these protocols to delegate. A manager, agent in the cloud might realize it needs local access and tries to call down to a local runner. But as Daniel pointed out, that often leads to those Frankenstein setups with tunnels and security holes. You're basically opening a door in your firewall and saying, "Hey, random cloud server, come on in and look at my files."
Let's talk about those frameworks for a second. In the cloud world, LangGraph seems to be the heavy hitter for complex cycles. It's great for when you need an agent to try something, fail, reflect, and try again. It's very state-heavy. If the agent gets halfway through a 20-step research task and the API times out, LangGraph knows exactly where it was.
And then you've got Crew AI, which is more about role-playing and multi-agent collaboration. They recently added A2A support, which is interesting. It allows a researcher agent in the cloud to hand off a subtask to a local file executor agent on your machine. But again, the plumbing is the problem. You need a persistent connection between the two.
And then you've got the local first heavyweights. Claude Code is the big one from Anthropic. It's a CLI that's just incredibly deep into your local Git and file system. It can run your tests, look at the output, and fix the code in a loop. And OpenClaude is the community favorite because it lets you swap out the brain. You can use a local model for the boring stuff and save the expensive API calls for the hard reasoning.
It's a funny contrast. Local first tools feel like power tools. They're in your hand, you're in control, but you have to be there to pull the trigger. Cloud native tools feel like factory robots. They're automated, they run while you sleep, but they're stuck on the factory floor. If you want the factory robot to fix your kitchen sink, you're out of luck.
So, the million-dollar question Daniel asked, can we have our cake and eat it too? Is there a hybrid model that doesn't involve turning my iMac into a bootleg server? Because I really want the persistence of the cloud with the eyes and hands of my local machine.
I've been thinking about this thin agent architecture people are whispering about. What if the orchestration logic, the instructions and the state lives in a synced repo, like your dot files, but the hands are ephemeral?
That's where remote MCP becomes the game changer. Imagine your agent's brain lives in the cloud. Maybe it's a LangGraph instance on a VPS. It's persistent. It's portable. But when you sit down at your desk, your local machine advertises its MCP servers to that cloud brain via a secure encrypted tunnel, something like Tailscale or a Cloudflare tunnel.
Oh, I see where you're going. The cloud agent reaches down into your machine only when your machine is online. It uses your local vision and your local files as temporary tools. When you close your laptop, the agent stays alive in the cloud, but it just loses access to those specific local tools until you come back online. It's like a ghost that can only possess you when you're wearing a specific headset.
Wait, I said the word. I mean, that's the path forward. It solves the portability problem because the brain is always in the cloud, but it solves the vision and local access problem because it uses the local machine as a sensor array. It's like a drone pilot. The pilot is in a trailer in Nevada, the cloud, but the drone is over the target, your desktop. If the drone loses the signal, the pilot doesn't die. They just wait for the signal to come back.
I love that. But does that compromise privacy? If the cloud brain is seeing my screen, isn't that data still leaving my house? Even if it's through a secure tunnel, I'm still streaming my desktop to a third-party server. It depends on where the inference happens. If the vision model is running locally on your GPU, maybe a small vision language model like Moondream or a tiny Llama vision, it could describe the screen in text. User has a Python file open with a syntax error on line 42. It sends that text description to the cloud brain. The actual image never leaves the machine. You're sending the meaning of the pixels, not the pixels themselves.
That's the sanitized reasoning Daniel mentioned. You use local inference as a filter. It's like a personal assistant who looks at your bank statement, says, you spent $50 on tacos, but doesn't show the cloud model the actual account number or your home address. It's a layer of abstraction that doubles as a security barrier.
It's actually more efficient too. Sending 1,000 tokens of text description is way cheaper and faster than sending a 4 megabyte PNG every 5 seconds. You're reducing the vision problem to a context problem.
So why aren't we all doing this yet? Why does it still feel like we have to choose between a local CLI and a cloud VPS? Is it just that the software isn't there, or is there a deeper technical hurdle?
It's the plumbing problem. Setting up a secure, low-latency tunnel that can handle MCP over Studio or HTTP between a VPS and a local machine is still a weekend project for a senior dev. It's not one click for a regular user yet. We're waiting for the frameworks to bake this in. We need the iCloud for Agents moment where the sync just happens in the background without you needing to know what a WebSocket is.
I bet we'll see LangGraph Local Sync or something similar soon. where the state is automatically mirrored. But in the meantime, I'm stuck dragging my JSON configs around like a digital nomad. I actually started keeping my MCP config in a private GitHub repo, just so I could git pull my personality onto my laptop.
There's also the vendor lock-in aspect. If you go all in on Microsoft's agent framework, you're probably going to have a great time as long as you stay in the Azure and Office 365 ecosystem. They'll handle the local to cloud bridge because they own both ends of the pipe. But the moment you want to use a local tool that isn't certified, or you want to use a model that isn't in their catalog, you're back to square one.
That's why OpenCloud and the MCP standard are so vital. If the hands and the brains speak a common open protocol, then the where doesn't matter as much. I could have a brain on a modal GPU instance, a set of hands on my MacBook, and another set of hands on my home server, all talking the same language. It's about interoperability. I don't want my agent to be a wall garden. I want it to be a park.
This actually reminds me of what we were talking about a while back regarding AI memory. If memory is fragmented between local files and cloud vectors, the agent is always going to feel a bit lobotomized. The hybrid cake model requires a unified memory layer that can live in the cloud but sync locally. Think about a RAG system, retrieval, augmented generation, that can query your cloud-based emails and your local source code simultaneously.
It's funny, we're basically reinventing the operating system, aren't we? The agent is becoming the new kernel, and we're trying to figure out how to handle distributed hardware. In the old days, the kernel managed your CPU and RAM. Now, the agent kernel is managing your local files, your cloud APIs, and your vision of the screen.
It really is a distributed OS problem. In the 90s, we had the network is the computer. In 2026, it's the agent is the workspace. Your workspace isn't a physical location or even a single OS, it's the sum total of everywhere your agent can reach.
So, if you're a developer listening to this and you're trying to decide where to build your next agent, what's the move? Do you go local first and deal with the silo, or cloud native and deal with the blindness?
If you're building for yourself a single user power tool, local first with OpenCloud is unbeatable for raw capability. The ability to just say fix the bug in this folder and have it actually happen in your terminal is magic. It's high fidelity, high agency. But if you're building something for a team, or something that needs to be always on, you have to start with a cloud-native framework like LangGraph and then figure out the local bridge later. Don't try to make a CLI act like a server.
I'd also argue that for individual developers, the .files approach to agent config is the best middle ground right now. Keep your agent logic in a Git repo. Treat your agent like your Vim or Zsh config. It makes the environment-bound problem a little less painful because you can just git pull your agent's brain onto a new machine. It's not true portability, but it's a hell of a lot better than starting from scratch.
That's a great practical takeaway. Your agent isn't an app, it's a configuration. If you treat it like code, it becomes portable by default. You can even use Docker containers for your MCP servers to ensure the environment is identical whether you're on Linux, Mac, or VPS.
I'm still waiting for the day I can just walk up to any computer, scan a QR code, and my agent possesses that machine for an hour, bringing all my local tools and vision capabilities with it. No installation, no config, just an ephemeral bridge between that hardware and my cloud-based brain.
We're not far off. With the way MCP is being adopted, we're basically building the USB port for AI agents. Once the hardware, the local OS, has a standard way to let an agent plug in, the location of the agent becomes irrelevant. We'll look back at this era of manual JSON syncing, the same way we look back at carrying floppy disks between PCs.
Possessed by an agent. That's a terrifyingly efficient image, Herman. I love it. It's like a digital ghost that helps you with your spreadsheets. But it raises a huge question about trust. If I let an agent possess my machine, I'm giving it the keys to the castle.
Better than a ghost that just rattles chains. At least this one can write Python scripts. But seriously, the Frankenstein architecture Daniel mentioned, turning your workstation into a server, is the growing pains phase. We're trying to force a local first tool into a cloud-shaped hole because we haven't built the proper bridges yet. We're in the tethering phase of the mobile internet, where you had to plug your phone into your laptop with a special cable just to get online.
It's the using a spoon to use your PC problem we've discussed. We're using clunky workarounds because the native agent to OS interfaces are still being written. We're waiting for that Wi-Fi moment for agents where the connection is invisible and ubiquitous.
What's interesting is how this affects the pro-American, pro-innovation stance we usually take. If the best agents are local, first, it favors individual sovereignty and privacy. It keeps the power in the hands of the user. It allows for a more decentralized, permissionless innovation. If the cloud-native model wins, it favors the big providers. OpenAI, Google, Microsoft, who can provide that seamless, always-on experience at the cost of your data living on their servers.
That's a huge point. The architectural choice isn't just a technical one, it's a political one. Do you want your resident assistant to be your employee, or do you want to subscribe to a service that manages your life from a distance? If it's your employee, you're responsible for the office it works in. That's the local config hassle. If it's a service, they handle the office, but they also get to overhear all the conversations.
I think the hybrid cake is the pro-liberty solution. You own the hands, the local MCP servers, and the local hardware. But you leverage the massive compute of the cloud for the heavy lifting, using encryption and local sanitizing models to keep the cloud provider at arm's length. It's the best of both worlds, high-performance thinking with local private execution.
It's the federated approach to personal AI. It feels very much in line with the local-first software movement that's been gaining steam. Tools like Anytype or Obsidian are popular precisely because they don't lock your data in a cloud silo. Agents are just the next layer of that stack.
And it's where the most innovation is happening. Look at the open source community around OpenCloud. They're moving way faster than the enterprise tools in terms of supporting weird, bespoke local tools. They've got MCP servers for everything from Home Assistant to local MIDI controllers.
Because they're building for themselves. They're building the tools they actually want to use, not the ones that fit into a corporate security policy. If I want an agent that can control my smart lights based on the code I'm writing, I can build that in an afternoon with the local setup. In a cloud-native enterprise environment, that would take 6 months of security reviews.
Though, to be fair, those corporate policies are why the cloud-native model is so dominant in the boring world. If you're a CTO, you'd much rather have your agents running in a controlled, audited VPS environment than on 1,000 different laptops with 1,000 different local configs. From a management perspective, the silo is a feature, not a bug. It's a sandbox.
True. The cloud is for control, the local machine is for power, and as a user, I always want more power. I want the agent to be able to see that I'm struggling with a CSS layout and just reach in and fix it while I'm watching.
But as we see with tools like Claude Code, the power is becoming too great to ignore. When an agent can cut your dev time by 50% because it has eyes on your local environment, even the most control freak CTO is going to have to find a way to allow it. They'll have to adopt these hybrid bridges just to stay competitive.
So, we're looking at a future where the edge isn't just a CDN for your website, it's the place where your agent's vision and local actions happen, while the core is where the deep reasoning lives. It's a biological analogy, really. Your spine handles the reflexes, the local stuff, while your brain handles the long-term planning.
I did it again. But yes, that edge-cloud split is the inevitable architecture. It's the only way to scale intelligence without sacrificing the ability to interact with the physical and local digital world.
You know, I actually tried to explain this to my neighbor the other day. He's not a tech guy, and I told him my computer has a brain in the cloud, but its hands are in my keyboard. He looked at me like I was describing a horror movie. He asked, "What happens if the brain decides to close your bank account?"
Well, when you put it that way, it does sound a bit Cronenberg-esque, but for us, it's just the next step in the evolution of the interface. We went from command lines to GUIs, and now we're going to agentic surfaces. It's not about the computer doing things to you, it's about the computer doing things for you with the same context you have.
I like that. Agentic surfaces. It's a fancy way of saying where the magic happens. It's the boundary where the AI's intent meets the machine's capability. Right now, that boundary is jagged and broken.
And right now, that surface is fragmented, but the frameworks are catching up. Whether you're using LangGraph in the cloud or OpenCloud on your desktop, the goal is the same, reducing the friction between your intent and the computer's action. We're trying to eliminate the translation layer where you have to tell the AI exactly what to do step by step.
And if we can do that without having to resync our JSON files every time we go to a coffee shop, we'll have truly arrived in the future. I want my agent to be like my shadow. It just follows me no matter what device I'm using, and it knows exactly what I'm looking at.
We're getting there. The Model Context Protocol is the first real universal translator for this world. Once every app and every database has an MCP server, the where of the agent becomes a secondary concern. The agent becomes a layer that sits on top of everything, rather than a program that runs inside something.
I'm just waiting for the day my agent can see I'm out of coffee and just order more, locally, through my browser, using my saved credit card, without needing an API for the coffee shop. It just navigates the site like a human would.
That's the computer use stream. And it's only possible if the agent can see the website just like you do. If it's a cloud-only agent, it's stuck waiting for the coffee shop to release a public API, which might never happen. Local vision bypasses the need for permission.
Local vision, cloud persistence. That's the cake. It's the ultimate power user setup.
And we're definitely going to eat it. It's just a matter of who builds the best fork first.
Hopefully with a side of that coffee. All right, I think we've thoroughly dissected the agent surface tension for today. We've gone from local silos to cloud brains and back again.
It's a fascinating time to be building. The landscape is shifting under our feet every month. What was impossible in 24 is standard in 26.
Well, if my feet are shifting, it's probably just because my agent is trying to reorganize my office again. It's convinced my filing system is suboptimal.
Just make sure it doesn't reorganize your keys into the trash. AI logic can be a bit literal sometimes.
No promises. I'll check the bin before I leave. Thanks for the deep dive, Herman. This was fun.
Always is, Corn. I'm looking forward to seeing how Daniel's prompt evolves as these frameworks start talking to each other more.
And a big thanks to our producer, Hilbert Flumingtop, for keeping the show running smoothly behind the scenes. He's the human orchestrator for our agentic discussions.
And of course, thanks to Modal for providing the GPU credits that power the generation of this show. They make the cloud part of our local cloud hybrid possible. Without that massive compute, we'd just be two guys talking into a dead mic.
This has been my weird prompts. If you're finding these deep dives into agent architecture useful, a quick review on Apple Podcasts or Spotify really helps other people find the show. It tells the algorithms that we're worth listening to.
Or you can find us at myweirdprompts.com for the full archive and all the ways to subscribe. We've got the transcripts and the prompt breakdowns there too.
We're also on Telegram. Just search for My Weird Prompts to stay updated on new episodes and join the conversation. We love seeing what kind of Frankenstein setups you guys are building.
Until next time, keep your hands local and your brains in the cloud, or vice versa. Just keep building.
Yeah.
Bye.
This episode was produced using Google Gemini 3 Flash. Text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My weird prompts, that's the close from sloth